Alright, a very good morning to you, my dear students. You are welcome to another mathematics class with Mr. Emmanuel Akpan. Remember the other time we looked at plane mensuration, where we calculated the areas and perimeters of sector of a circle. Today we are going to look at another part of a circle, and that is segment. Alright, I urge you to be with your new concept mathematics, preferably the 3rd edition, so that we can be on the same page. Alright. Now let's consider the behavioral objectives of this lesson. At the end of this lesson, you should be able to calculate the perimeters of segments of a circle. Calculate the areas of segments of a circle. We have to calculate the perimeters and segments, perimeters and areas of segments of a circle. Alright. Now the first thing we are looking at is segment. Before we can calculate the areas and perimeters of segments, we need to understand what a segment is. Now, a segment is that part of a circle that is bounded by a chord and an arc. Every segment has a chord and an arc. Now let's look at figure 7.1. In figure 7.1, from P to Q is the chord, and PXQ is the arc. Okay, you can see this shaded portion, that is a segment. But I want you to know that this shaded portion here is the minor segment. Let me show you, because in a circle we have a major and a minor segment. Now let's assume that this is a circle. Okay, this portion that I'm trying to shade serves as the minor segment, and this one up here is the major segment. Okay, so in this diagram, the area that is above the chord PQ serves as their major segment. Okay, and this is the minor segment. Alright, so let's see how we can calculate the perimeter of segment, because after now we are going to calculate the perimeter of segment, and I want to use the triangle that is here. This is an isosceles triangle. I want to use it to show you how you can get the length of a chord, because we have done that of the arc before now. So in this triangle that is here, call this triangle 1, and this is 2, and you can see that it is a right angle triangle. With that understanding, let us apply the trig ratios and see how we can determine the length of the chord PQ. Now in triangle 1, you can agree with me that sine theta over 2 will be opposite over hypotenuse. This is the angle that we are considering. Remember that the angle that is here is theta. So since we are dividing the triangle into 2, we now have theta over 2. So the angle is sine theta over 2 is equal to RQ over R. That is opposite over hypotenuse. You will see the write-up when I move to the next page. Now that you have gotten an expression for sine theta over 2, you will now make RQ the subject by cross multiplying, and when you get the RQ, or you call it QR, you multiply by 2 to make room for P to Q, because the point R is the perpendicular bisector of the line PQ. Okay, so for us to have PQ, we need to multiply QR by 2. All right, let me show you the workings here. Okay, perimeter of segment is gotten by finding the length of chords and the length of an arc. Okay, length of a chord in figure 7.1 that I've just explained to you. Triangle POQ is an isosceles triangle. The perpendicular bisector of OR bisect the angle POQ and the chord PQ. Okay, everything you see here was what I was trying to explain to you. Okay, you can see the sine theta over 2, opposite over hypotenuse. You now make QR the subject, then you multiply by 2 to get the length of chord. And this is the formula for calculating the length of a chord of a circle. Take note of the formula here. Having gotten the length of a chord, let's now write the expression for the perimeter of segment. This is the length of an arc. That is a fraction of the circumference of the circle plus the length of the chord in question. So this is the formula we are going to use to find the perimeter of segment. All right, let's consider example 1. Calculate the perimeter of a segment which subtends an angle of 72 degrees at the center of a circle of radius 7 cm. We are to find the perimeter of a segment which subtends an angle of 72 degrees at the center of a circle of radius 7 cm. Take pi to be 22 over 7. In fact, throughout the calculations we are going to do, pi will always be 22 over 7. Okay, now how do we go about this problem here? The first thing you have to do is to list the parameters that are given in the question. Okay, so we are given the angle at the center, we are given the radius and pi to be 22 over 7. So what do? We now find the perimeter of segment. But before we do that, we need to have a sketch of the problem for better understanding. We need to sketch the problem. Okay, this is a sketch. You can see this is the radius and this is the theta divided by 2. Since the angle at the center is 72, okay, it means that the whole of this place is 72 degrees. Since we are dividing it by 2, okay, so that we can find the length of the chord, we now have 72 over 2. With that, let us use the formula that I gave before now. Okay, now this is the formula for finding the perimeter of segments. I would like to solve for the length of an arc before that of the chord, then we will sum the two together. So length of chord is 2r sine theta over 2. Okay, you now put the parameters that we have listed out before now. This is 2 multiplied by the radius times sine 72 over 2. Okay, and that takes us to 2 multiplied by 7 is 14, multiplied by 72 divided by 2 is 36. Okay, so when you find sine 36 from the table, you have it to be 0.5878, and you get your final answer by multiplying 14 by 0.5878. all right, so the answer is given to 1 decimal place. With that, we go ahead to find the length of the arc using this formula here. We have it to be theta over 360 multiplied by the circumference. Okay, that is 72 over 36, 360 rather, since the angle at the center is 72 degrees, multiplied by 2. Theta pi is 22 over 7, multiplied by 7. Okay, now how do we get this 1 over 5? 36 divided by 360 divided by 36 is 10. Very simple. Then 72 divided by 36 is 2. You can agree with me that 2 over 10 can be reduced to 1 over 5. Okay, and then this 7 that is here will cancel this one here. It's going to cancel that one. This 7 here will cancel this one. We are now left with 2 multiplied by 22. That is why we have the 44. Okay, now 44 divided by 5 is 8.8 cm. At this point, we can now find the perimeter by adding the two answers, the length of the chord and the length of the arc, and our perimeter is 17 cm. Now, how do we obtain area of segment? If you look at the figure that is here, for us to get the area of the segment that is here, we need to first of all find the area of the sector. Okay, you have seen the shape that looks like a cone inside this circle. That is the sector of the circle. So we need to find the area of the sector first. Then we will now subtract the area of the triangle that is here. We now subtract the area of the triangle. You can see the triangle POQ. Okay, this is a triangle I'm talking about. POQ is an isosceles triangle. So we will first of all find the area of the sector and minus area of the triangle, and we'll be left with area of the minor segment that is here. All right. Okay, so area of sector is theta over 360 multiplied by area of a circle minus the area of the triangle. Take note that this expression that is here represents the area of the triangle. I don't want to bother you with the proof of how we got the area. Okay, at this point, I urge you to apply it. Then in due course, if you get to know how we got the area. Okay, now let's take example. A segment of a circle whose radius is 7 cm subtends an angle of 135 degrees at the center. Calculate the area of the segment to 2 decimal places. Pi is 22 over 7. I take the question again. Segment of a circle of radius 7 cm subtends an angle of 135 degrees at the center. We are to calculate the area of the segment to 2 decimal places. Okay. As before, we will have to list the parameters that are given to us in the question. Okay. Then we go ahead to sketch the problem, making use of the parameters. You can see the radius here, 7 cm, the angle is 135. Okay. With that, we go ahead to find the area of the sector and that of the triangle. Okay. Area of segment is equal to area of a sector minus area of triangle. Okay. Before now, you know how to find the area of a sector, so I'm not going to spend more time on that. We juxtapose the values that are given to us, that is 135 over 360 multiplied by 22 over 7 times 7 times 7, that is r to power 2. Okay, and 135 over 360 can be reduced to 3 over 8. We can confirm that, and the 7 here will cancel this one, and we are left with 22 multiplied by 7. Okay, now 3 over 4 times 11 multiplied by 7. How do we get the 4 here? By dividing this 8 by 2 and 22 by 2 to have 11. With that, we have 33 times 7 over 4. That is 3 times 11 multiplied by 7 divided by 4. That will give us 231 divided by 4. We have 57.75 cm square. That is the area of the sector. Now let's find the area of the triangle. This is the expression for finding the area of the triangle. Half of radius to power 2 multiplied by the sine of the angle that is given. Okay, and that will, we now have 1 over 2 multiplied by 7 times 7 multiplied by sine 45. Now sine 45 is the same thing as sine 135, since they are supplementary. That is, they sum up to 180, so they give the same value. Okay, since it's very possible to get sine 45, that's why I'm using sine 45 here. Sine 45 is a special angle. Okay, so we now have 7 multiplied by 7 is 49 divided by 2, that is here. Now sine 45 is root 2 over 2. When we manipulate that, we have 69.296 divided by 4, and our answer is 17.32 cm square. Okay, at this point we can now find the area of segment by subtracting this area of the triangle from the area of the sector here. Okay, area of segment is 57.75 minus 17.32, and our final answer is 40.43 cm square. Remember, the question says we should take it to 2 decimal places, and that is what we have just done. Okay, with that, we will move to example 3. Remember to find area of a sector, that of the triangle, and you subtract the triangle from the sector to have area of minor segment. Okay, example 3. Calculate the area of a major segment whose chord subtends an angle of 85 degrees at the center of a circle of radius 3 cm. Pi is 22 over 7. So far we've been looking at minor segment, because that is where the work is. Okay, now we have to find the area of the major segment. Okay, for you to find the area of the major segment, you have to first of all find that of the minor segment. Let's look at it. So area of major segments is gotten by finding the area of a circle, then subtracting area of minor segment. In other words, we still have to pass through the step of finding area of minor segment before getting that of the major segment. Okay, so as before, we list the parameters that are given in the question. We sketch the problem. Remember, this is the part that we are looking for. Sorry, this part that is above the chord PQ. Okay, apart from the shaded, the minor segment, any other portion up there is what we are looking for. So it's very clear that we need to find the entire circle, then we now take away this part here. Okay, so let's see how we can do that. Okay, first of all, we find the area of a circle. Do I need to show you how to find the area of a circle? I don't think that is necessary. At this point, you should be able to find the area of a circle. So when you put the parameters that are given to you, we have 28.29. Okay, now this is an opportunity for you to go through the steps in finding area of minor segments again. Remember that before now I used to find them separately before carrying out the subtraction, but since you are already used to it, that's why I have to match the two at once. So this, the left hand side here is for the area of the sector, and the left hand side here is for the area of the triangle. We just put the values, the angle that is given, divide by 360, 22/7, r squared means 3 times 3, minus 1/2 times 3 times sine 85. Okay, when we evaluate that, we will have 85 times 22 times 9 all over this, and 9 multiplied by sine 85 from the table is 0.9962 divided by 2, that is here. Okay, with that we have 6.68 minus 4.48, and that is 2.2 cm square. All right, what we have to do now is to find the area of major segment by subtracting this from the area of the circle. Okay, and that gives us 26.09 cm square. Okay, you can always go back to study it where you don't understand, go through it again, and you get better understanding. Okay, so far we've looked at the definition of a sector, definition of segment as that part of a circle that is bounded by a chord and an arc. We've also gotten the perimeters of a sector of a circle and the areas as well. And I've said that for you to get the perimeter of segments, you need to first of all find the either length of chord and add it to what length of the arc in question. Okay, and then to find the area of the segment, you need to first of all find area of sector and take away area of the triangle that is part of the sector, and you'll be left with the segment. I believe that is clearly understood. Now when you are asked to find the area of the major segment, you need to change the calculation a bit by first of all finding the area of a circle, then you subtract the area of the minor segments, and you'll be left with what? Area of the major segment. With that, we have come to the end of today's lesson, and this is assignment for you. Okay, feel free to send your questions and comments to SS1@brightfuturecollege.com, or you forward it to my WhatsApp number that is displayed on the screen for you. I remain your mathematics teacher, Mr. Emmanuel Akpan. Thank you very much for having me.